As we all know that 18 group elements do not generally combine, they are less reactive because, or you can say they are non-reactive because their octet is actually complete, they have stable electronic configuration. But still xenon and krypton form certain compounds with fluorine and oxygen. So we are going to study that. So we are going to study the xenon fluorides. So what happens in xenon fluorides? Xenon actually react with fluorine in presence of nickel, approximate temperature 673 Kelvin, pressure 1 bar, and it forms XeF2. Its fluoride is not limited to this, and actually form further fluorides also. Like if we react Xe with 2F2, again in presence of nickel, but temperature being higher, even the pressure being higher, we see that it forms the fluoride with formula XeF4. Likewise, if we react Xe plus 3F2, again nickel, temperature being 573 but pressure being very high, that is 60 to 70 bar, we will see that it will form fluoride with formula XeF6. So these are actually the common fluorides which xenon forms, that is XeF2, XeF4 and XeF6. Now how they look like? The question is that how they look like. They are all crystalline. They are all crystalline, and you know that they are volatile, therefore this shows sublimation, they sublime readily, and you know that they are actually fluorinating agents also. They are fluorinating agents also, that means they can donate their fluorine. For example, I have platinum, I am going to react with XeF4. Actually all of these three are fluorinating agents. So what do we get here? We get platinum fluoride and xenon gets separated. So this is proof that actually it can give its fluoride. Likewise we have suppose SF4, we react it with XeF4. So what happens? Suppose I react with XeF2, it will form SF6 and Xe will be liberated. So they act as actually fluorinating agent. Likewise they react with covalent fluorides also. Their reaction with covalent fluorides, like I have let's say platinum fluoride, I am going to react with XeF2. So what happens? It donates one of the fluorine to PTF4. So what does it become? It becomes XeF positive and PTF5 negative. So this you have seen that it is donating one of its fluorine to here, right? So or you can say it acts as an oxidizing agent. Likewise, suppose I have in this also we have seen the same way, it is donating its, but it is donating all of its fluorine to here, but here if we react with it, it will donate only one fluorine in one step. So it will become SF5 negative. First I will write the positive part. That is XeF negative, positive, and SF5 negative. So likewise it can act as a, again you can see that it is oxidizing and it is a reaction with the covalent fluorides. So moreover it's one more important reaction with water. It gets hydrolyzed. So if we take XeF2 and we react with water, we can also hydrolyze XeF4 with water. We can also hydrolyze XeF6 with water. We will get different products. The reaction is somewhat slow in this case in the XeF2, and what is the product here? It is Xe plus HF plus oxygen. This reacts somewhat violent, and even the reaction of this is violent. And what does it produce? It produces xenon with xenon trioxide with HF and O2. This compound which is formed is explosive in nature. This is highly explosive. Likewise, we have XeF6 plus H2O. So when it will react, it will form only a compound, explosive compound, xenon oxide, trioxide with HF. So these are the reactions that when they get hydrolyzed. So you should know that because these reactions are very, very, very important. it reacts slowly and it forms Xc, HF and O2. XeF4 react violently, it forms Xc with an explosive compound HF and O2. Xenon, this thing XeF6 rehydrolyzed, again an explosive compound and HF. So this is how they get hydrolyzed. But when they are partially hydrolyzed, let us hydrolyze partially, not this one. We can hydrolyze partially XeF4 and XeF6. So when we partially hydrolyze it, what compound we get? We get xenon oxyfluoride, XeOF2. And when you partially hydrolyze XeF6, we get XeOF4. That means F from 2 becomes F4. Same HF. And likewise, if you react with XeF6 but 2 moles of water, you get XeO2F2. So these are the products actually which are formed as a result of partial hydrolysis of xenon fluoride, which one? XeF4 and typically XeF6. So these are important compounds. As you can see that, as you all know that we have a question in our mind that the noble gases do not react, but we see that under specific condition of temperature and pressure or with specific substances, xenon and kryptons are actually reacting and they are forming a certain kind of compounds, mostly the xenon fluorides and the oxyfluorides. So this is what is the compounds. Now we will be discussing their shapes, because the shapes are playing an important part here, and you have already done its shape in chemical bonding, but still to revise that, we will discuss their shapes of xenon oxides, xenon fluorides and xenon oxyfluorides. So just look at them.